Okay, this video is a fairly short video. We're going to be talking about 11.3, geometric sequences and series. And first thing I want to do is just kind of revisit what the arithmetic sequence looked like. So the arithmetic sequence was a sequence like 5, 12, 13, 5, 14, 12, 19, excuse me. You can see that the sequence goes up by the same amount each time. So 5, 12, 19, that's up by 7s each time. And if you wanted to find the 100th number, you could use a 100 equals first term plus 99 common differences, 99 sevens, that is, so 99 times 7. Or you can just use this general formula right here. This is a really cool little formula in yellow, and it basically is saying, I'll highlight it, I'll put the green asterisks next to it. This is just saying that to find any term, you can take any term and add n minus k times d, where k and n are the subscripts of the terms. So that's a nifty formula. What does the word series mean? Series means you're not going to be using the commas. Here, see the commas? Instead of listing, you're going to be adding, so you're going to be putting in pluses. That's what we call a series, okay? So series, the only difference between a sequence and a series is that a series is added up. Okay, it's added up. So 5 plus 12 plus 19, etc. Okay, and then if we want to add 5, 12, 19, etc., you just have to tell me where you want to stop, and that's a sub n, and then you can use this formula here. So I'll put asterisks in green next to the formula here. I'm talking about this formula right here. This formula helps us. Okay, we can actually find the sum of the first 1,000 terms. Not too hard to do, actually. I just want to remind you that sometimes you actually need to use the first formula here to get an. So that happens sometimes. If you don't know an, you might have to actually find an before you can find the sum of the first n terms. Okay, geometrics are similar in concept, but not in practice. So, like you can see that a geometric sequence is formed. Let me erase some of this work. Geometric sequences are formed by basically multiplying by the same number each time. So instead of adding 7 each time, you might multiply by 7. Well, here's a sequence that the student created where we went 5, 10, 20, 40, 80. The student was simply multiplying by 2 from one term to the next. That means that if the student wants to find the 100th term, they could simply take the first term and multiply by 2 99 times. So we call this an R equals 2G sequence. So you could just multiply by 2 99 times. In general, if you wish to find a general term, this formula with the green asterisks next to it is stating that you can take any term, a sub k, multiply by r, n minus k times, and you'll come up with the nth term. Okay? The s sub n formula is a little bit harder to create. That's this one with the double asterisk next to it. And so I'd like to show you how that comes about real quick. So we know that s sub n means add up all the terms, the first n of them, you see. So I'm going to try and add a1 and a1r and a1r squared and a1r cubed all the way up until the last term, which is a1r to the n minus 1. I'd like to add them all up, but I'm too lazy to actually physically add them, so I'm going to try to create a formula that will do it for me. So the first thing I'm going to do is I'm going to multiply this, what I've just written, by r. Now granted, this is a trick that you might not think to do, but watch how well it works. Okay. So I'm just multiplying this all by r. And so I'm going to distribute this into all the terms. Okay? So I'm going to actually leave this right here on my page, this yellow one. This will stay here. Okay? But I'm going to go and distribute now and see what I get. I'm going to get a second formula. Right, so the second formula is going to read, pardon the extra work down at the bottom there. The second formula, when I distribute, it's going to read this now. RSN equals A1 times R plus A1 times R squared plus a1 times r cubed plus a1 times r to the fourth plus blah 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 plus a1 r to the n. So what just happened was I distributed, and each of these terms here in red gained a power of r. Okay, now highlight that one in blue. Okay, so what happens when we take the yellow and the blue and subtract them? Let's see what happens. Okay, so I'm going to switch colors now. I'm going to go to purple. What happens when you take S sub n equals a1 plus a1r plus a1r squared, etc., which terminates at the general term, and subtract rs sub n equals a1r plus a1r squared plus a1r cubed plus dot dot dot, which terminates at a1r to the n. Well, most everything cancels out. Almost everything cancels out. You'll see that the a1r cancels out. The a1r squared cancels out. The a1r cubed will cancel out too. I didn't write its partner, but it would be in the first line of work also. Okay? And eventually, even the a1r to the n minus 1 would cancel out. The reason is the second list has an a1r to the n minus 1. It's just prior to this term that I wrote last. So just before this green term was the term a1r to the n minus 1. So the only things that survived here were these four things. And so it looks like this now. This side says s sub n minus rs sub n equals a1 minus a1r to the n. And since we seek a formula for s sub n, let's go ahead and factor out an s sub n on the left and an a sub 1 on the right. So s sub n is a1 times 1 minus r to the n all over 1 minus r. And this little handy formula will help us add up the first 10 terms, let's say, of any geometric sequence, provided we can figure out what r is. Okay, go ahead and take a moment and write down this example. It says find the next three terms in the general formula. I'll put an and in there. Then find the sum of the first 10 terms. Okay, so after examining this, you can pause it and do it if you like. After examining this, you can realize that the basic idea is that we're doubling. Right? In fact, this is the same sequence we were talking about a few minutes ago. So we're multiplying by 2 each time, which makes it geometric, and it means that our next terms are going to be 80, 160, and 320. So we kind of did our first part of this. The second thing it asks us for is a general term, or a general formula, or an explicit rule. There's lots of names for it, but basically you're trying to find, let's say, the 1,000th term. How would you do it? Well, you would take the first term and multiply by r n minus 1 times. That's the general rule. So since our first term is 5, and our r value is 2, this would be what we mean by a general term. You may not multiply the 5 and 2 to make 10. Okay, you may not. Okay, part 3 here, the third question, asks us for the sum of the first n terms. Okay, so if this formula right here that we just found had a purpose in life, it would just simply be to help us find, say, the 10th term or 12th term or something. This next formula that we learned and actually derived a few minutes ago was a sub 1 times 1 minus r to the n over 1 minus r. We worked very hard to get that. That thing's job is to add up the first n terms, let's say. So basically, if we're going to be finding the sum of the first 10 terms, we would simply seek to use n equals 10 and write s sub 10 equals, okay, the first term, 5, times 1 minus the common ratio to the 10th all over 1 minus the common ratio. So you basically get 5 times 1 minus 1024 over negative 1, or you could just simplify this to be 5 times 1024 minus 1. So I basically multiply top and bottom by negative 1. So what is 5 times 1023? I believe it's 5,115. Let's just check real quick. So 5 times 1023, 5,115, 5,115. Okay, so let's put that in here. 5115 S sub 10. Okay, let's try another example. Okay, this next example is from Solomon and Sullivan, example 9, and on page 879. It's from the 3rd edition of the textbook. So let's say that you wanted to, let's say you're given that a pendulum initially swings along an arc of 18 inches. On each successive swing, the length of that arc is 0.98, the original, or the arc, the length of the previous arc. So basically what's happening is this thing swings 18 inches going across, swings 18 inches, but coming back it doesn't swing 18 inches, it only swings back 17.64, you see? And then it swings back 98% of that. See, the common ratio is 0.98, so the object can't actually attain a length of 7 on its backswing. In fact, it's diminishing as we go. So the pendulum is diminishing in its amplitude, its swinging amplitude, you see. Okay, so you could kind of write this as a sequence. 18 is the first term, 17.64 is the next term, and so on. Okay, so they're going to ask us a lot of different questions about this sequence. Okay, so the first thing they ask us is what the length is upon the 10th swing. Okay, so let's see if we can figure that out. So part A asks, what is the length of the 10th swing? So you're basically looking for, I guess, A10 is the idea, right? So you're looking for A sub 10, but that would be found by doing A1 times R to the 9th, right? So since the first swing was 18, that's the first term in your list here, and the common ratio is 98% of that, basically each of these is 0.98 times the previous. So each swing is 0.98 times the previous. Also, you can also say 98% of the previous. So if you type this into your calculator, you'll see the answer. It's 15.007 inches. So it started out by swinging across 18 inches, but after 10 swings, it's only doing 15 inches, roughly. Make sure you have that nearest thousandth look, right? We talked about that. Okay, the next question is, on which swing is the length of the arc less than 12 inches? Less than 12 inches. Okay, so what you have to understand here is that there is a certain term in the sequence that's less than 12. It's the first sequence term that is less than 12. So we know that we're seeking a term in the sequence that is less than 12. Now we don't know what n is, so we're just going to do our best and just write 18 times 0.98 to the n minus 1. Our goal is to find which n makes this true. Now you can kind of hunt and peck on your calculator and try playing around with n. Pick the smallest n that makes this true, but I don't think that's really the best way to do this. We learned logs for a reason in the beginning of the year. So we're going to divide by 18 on both sides. This gives me 0.98 to the n minus 1 is less than 2/3, basically. Then the log will get that n minus 1 down. So logs have a way of doing that. We're going to put an ln here. This allows us to bring the n minus 1 to the front. Okay, this next part's a little tricky. Watch close. I need to isolate n, so I'm going to divide by ln 0.98. But what you may not realize at this point is that ln of anything less than 1 is negative, so technically this is going to flip around. So the inequality just reversed, and that's because ln 0.98 is negative. ln of anything less than 1 is negative. Even the ln 2/3 is actually negative, but we didn't divide by that. So, okay, so I flipped that thing around. If you needed decimals on the previous step, I guess you could have started your calculator work up here where the black asterisk is. But I'm trying to hold off on the calculator till the very end. Now I'm going to add that 1 over, and now I need my calculator. So I guess use your calculator whenever you feel you need it, but you can now type this in, and n is basically greater than 21.07. So which swing is greater than 21? That'd be the 22nd swing. So the 22nd swing is the first swing that is less than 12 inches in arc length. Okay, so there's your answer. Part C says, I'll switch to green. Part C says, after 15 swings, what is the total distance that the pendulum has swung? What is the total distance that the pendulum has swung? So you have to understand on this one is that we're doing 18 and 17.64 and so on, but we're going to add them up. And we seek 15 terms to be added together. So this is exactly what that SN formula does. So SN would be S15, you see. It's first term times 1 minus R to the n, that's 15. So I like to use brackets on the top. Over 1 minus R. Just be careful how you type this. Lots of parentheses. Or do numerator and divide by 0.02. Okay, just be careful not to mistakenly type without parentheses on the bottom. Or just type 0.02 to avoid it. Let me get my calculator out here. So I'm going to type 18 times 1 minus 0.98 to the 15th. And I typed that wrong. It should say 1 minus 0.98 to the 15th. And then that's going to get divided by 0.02. So the answer is 235.288. 235.288. So what does this mean? Well, it's swung back and forth several times, and basically this is how many inches it's traveled in total. Okay, let me show you how you can also enter sequences on your calculator, because somebody asked during second period, and I kind of felt bad that I kind of skirted it under the table. So let's go ahead and take a look at how you could have made your calculator do this problem. Okay, so one thing we haven't done much of this year is go into the catalog. If you go to catalog, you'll see an alphabetized list of functions, and it goes A through Z. If you go up from there, you'll see symbols like question marks and pies and stuff like that. Some of this is just used if you're writing a program. Okay? To get back to the A's, you can just simply tap whichever key has an alpha letter A. So for me, that's the math key. You can see if you look closely, right there next to my cursor is a little tiny A. See it? Okay. So if you want to see the B's, tap B, C, catalog. D is actually on the next line right here. D, E, F, G. So you kind of scroll through histograms. Lots of cool stuff, actually. We're going to go down to S is where the sum is, sum. So scroll down to S and then scroll through the S's until you reach sum, S-U-M. Where is it, where is it, where is it? There it is. Press enter. Okay, now go back into the catalog and go back down to the S's. You can tap S to get there. We're going to go to sequence, and there's two SEQs here. Sequence with the parentheses and sequence without a parentheses. We want the first one, the one I just circled. So we're going to put our cursor on that guy and choose it like that. And now we're going to type the explicit rule or general term. it was 18 times 0.98 to the n minus 1. Now to get the n minus 1 look, you can just do alpha n minus 1, or you can just use x. Okay, now that you've typed the sequence explicit rule, you're going to type comma, and then you're going to type the independent variable again, so alpha n or x if you used x. And then you're going to tell it which n's to use. We're going to be adding the 1st through 15th. So I typed it basically like this. Sum of sequence 18 times that should say 98, not 998. So let me start over. Sum of the sequence 18 times 0.98 to the n minus 1 as n goes from 1 to 15 is how the calculator understands this. There's your 235.288. And that concludes our lesson. By the way, I don't think that's too much faster than what I did the first time, so that's why I don't usually teach in class.